So welcome. Good morning, good afternoon, good evening. Welcome to our next lecture on architectures of AI systems. Today we are going to talk about containerization with Docker. So we'll cover Docker idea, potential use cases, and key skills which may be helpful in development of containerized applications with Docker. When we look at the place of this lecture in the whole course, we are here in the operationalization stage. Modularization, containerization, so using Docker is here. And it will obviously serve as a baseline for MLOps automation. So let's recall a kind of the context. In a typical machine learning pipeline, data science pipeline, we have many artifacts. Like here you can see different files and components like data prep, train prep, evaluate by different scripts. In your pipeline, it may happen that you will have different data sources as a producer for a pipeline and some different consumers like databases with their final users. And somewhere in the middle, you will have components which in a typical large-scale deployment may be spread over multiple servers. So if it's a large-scale deployment, it will probably won't be possible to serve everything on a single server. That's why we need a kind of the technology which will help us to distribute those Dockers, those components into different places. And for this, we are going to use Docker. Very important fact, a given container, given component may run on different servers. That may be a computer, that may be a server, or another computer. So we can compare it to such a component can compare to, for example, a source code of the Microsoft Word, and the container which we are going to use is a runnable, compiled and run on a given instance. So for that, as I mentioned already, we are going to use the Docker, which is, by the way, not the only one solution of that type on the market. There are some others, but the Docker is definitely the most popular. We are going to work in 3 steps. Firstly, and this is quite a general workflow, we will set up the account on the Docker.com. We create a Docker application, a source code, for example, and Docker Hub repository. Once again, you can store your Dockers either on Docker itself or in a repo of your cloud provider. Next, we are going to build the image. We'll take your application and then using Docker build command with Dockerfile specifying the requirements for this image, we'll compile the image, create the image. And finally, we will take this image and using Docker run it as a runnable as a container, and we'll run it locally or publish it and launch it in another system. So this is the most typical step. Obviously, setup is just a one-shot thing, but later then we are going to work with the images and containers. But before we start with some technical introduction, you'll find a lot of different examples in my folder. Let's talk briefly about why is it useful to learn Docker, what are the possible use cases. So firstly, coming back to our previous lectures on code engineering, it will help us to ensure portability of your code between computers, environments, and systems. So, as I mentioned, as you obviously know, a given source code may be later on be used by different people using different operating systems, different hardware setups. And in order to ensure portability, Docker is a really good choice. Next, we can reuse components provided by others. These others may be either your team members in your project or a community. As you can see, Docker Hub is a hosts more than 100,000 containers created by either individuals or some companies which provide the most often used components for their libraries. So reusability is another benefit. And finally, reproducibility. So having such Docker containers and in more general way containerization, we are able to reproduce the results of other teams or future selves. Next, moreover, it will improve our productivity. Thanks to those solutions, you will see many different use cases in the machine learning context in a few minutes from now. It will help you working more effectively with other people, other team members. So, how to use Docker in data science projects? What are the typical use cases? This is a compilation of my experiences of my friends, and what I also found in the internet. So I tried to compile all of them because it may inspire you to some more advanced usage of containers in your practice, specifically in machine learning projects. So firstly, first dimension, organization. So within your organization, within your team, it might happen that you want to quickly bring a new employee into the project. So you have a new employee is joining your team, and you want to onboard this, and you want to quickly prepare a machine, for example, PC, server, notebook for her or for him. So instead of installing a set of packages, we can run a Docker container. So we do not have to go through very complicated process of setting up the machine. Just simply take your Docker container through your project and have everything installed. So this is very useful, specifically if you work on computer vision projects or large language model projects where you have a lot of very specific libraries, interdependencies, specifically for CUDA, CUDA environments. So this is the first use case. Next, also very typical. You frequently change your location, you travel, return home, etc. You want to continue working on your project from another computer. You'd like to be able to perform those computations, train models, test applications, etc. They differ not only in operating system, but also in the environments installed on them and the hardware configuration. So in particular, some of them cannot use gas pedals like as graphic accelerators like graphic cards. So instead of installing dedicated environments on each of them, you run the Docker container with different parameters for with or without GPU acceleration. So that's when you come back home. And next, development. Imagine that you want to quickly test the performance of a new machine learning library. However, you do not want to create a dedicated virtual environment, install the appropriate packages, etc. So just you acquire the official application, you get it from the, for example, cloud or Docker Hub. Everything is correctly, properly configured, and you can run it as a component on your local machine. That was the case for me many times for PyCaret, which was very difficult to install some time ago because it had very strange requirements concerning, for example, different versions of pandas, etc., etc. So I had to create a dedicated environment, content environment for it. Not now, if I would like to test the newest version without creating new environment, I can just simply download the Docker container and run it just with 2 lines of codes, as you can see, precisely one Docker run. As you can see, this command will take the container for you and you have everything prepared. Next use case, I want to create a new machine learning service by combining off-the-shelf components like with Lego blocks. So you can use the components stored in Docker Hub, and link them together in a pipeline using Docker Compose. We're going to learn Docker Compose as a way of combining different Docker containers together into a single pipeline. So, once again, you can create your app as of Lego blocks using containers provided by different providers. Next use case. Imagine that you want to demonstrate a machine learning application to other team members, but so that they can experiment with the relevant components themselves if necessary. For example, change data, training algorithms, create the final app, etc. So you provide them with a Docker image with the appropriate environment and a set of source codes, so they are capable to not only run the code but also modify it. Next, sharing. That's only so we move from development to sharing. Firstly, I want to share an application using a database with others. So imagine that you have that database app and like Redis, PostgreSQL, MySQL. You want to make it available to people who do not have it installed, nor can they configure and manage it. So in many cases, there are some people who have no technical skills to install and run and maintain such a database on their computers. So you can use Docker Compose to create a multi-container application containing both the app and the corresponding database. So there is no problem on your colleague side to install and run it. So once again, the app combined with the running database in a single container, or multi-container app in a single app with multiple containers. Next, also a very typical use case for me. Imagine that I want to train managers on different aspects of machine learning, on data science. These managers have no technical skills to install all the required environments on their computer, or even they do not even know what the conda is. They do not know how to use pip install, conda install, whatever, poetry. And you do not have time to work with their computers before the workshop. So just simply ask them only to install the Docker, which by the way may be blocked by administrator, but in many cases if they have private computers it shouldn't be a problem, and then run your container. So it will directly run not only the dedicated environment, but you can also directly call Jupyter Notebook with all the required files, and precisely in a minute you have everything smoothly running on the computers of many people you are training. So that's also a possible use case. And next, by archiving the project, I want to ensure the reproducibility of my solution in the future. I document and publish my solution Docker image in the image repository accordingly. So this is for your future self. It's like a personal GitHub. You have all the requirements installed, and then after a few years you can come back and quite easily get your job done. Just to recall all the settings of a previous app. So that's the repo of your project. Next, development. Imagine that you wanna pass host-specific data to the container, for example, runtime parameters. You can use Docker bind mount for this purpose. So you may have quite an universal container, but it may use different runtime parameters depending on whether it's your on-prem server or cloud hosters in a given cloud provider. So you can pass the environment, hardware environment, for example, runtime parameters directly to the Docker, so that becomes even more universal. Next, you wanna ensure the continuity of your application. So that subsequent container runs with your application can use the results of previous runs. So you can use Docker volume for this. So you may have a local system, you may have a container, you may have and external volumes, so you can interchange the data between those environments. So you have a continuity of your application. So one Docker container is running, completes the job, it saves the file somewhere in the local system, and then it's or some external volume, yes, volumes. So you can then later on pass those data to another container and another container. So you have the continuity ensured. Next, I wanna different containers to exchange data. So you can once again use Docker volume for this purpose. Or I want to store the data used by my containers with a cloud provider. I use Docker volume for this purpose. Once again, I can exchange the data between my container, for example, running locally, with data in the cloud. Next, I want to simulate a production environment. That was one of the cases I had a few years ago when I was collaborating with some computer vision company, and deploying the image recognition systems on NVIDIA Jetson Nano endpoints. And this is very specific type of hardware with the software, and we wanted to simulate the behavior of this Jetson Nano endpoint on your workstation. So once again, you can get the Docker container which runs both on the both machines, and you can easily simulate this on your local computer. And then when everything is done, when it passes your test, you can deploy those containers to the edge device. Or you may want to run multiple services or sequence of services on the edge devices. Once again, to do this, you can use Docker Compose to create and launch of several services, parallel or in the appropriate sequence. Once again, this is a kind of the pipeline, but on the edge device like the camera or smart sensor. It's also possible. So, as you can see, possibilities are almost endless. And for example, you may also want to run your machine learning project in a scalable environment such as Kubernetes or GCP, Google Computing Platform, Azure, or EC2. So you create a separate image for each component of your machine learning process pipeline, and then you can use the Kubeflow system to manage the full process in Kubernetes. And thanks to the Kubernetes interfaces on these provider services, you create a single code which may later then be managed and run on different cloud providers. So that's portability is really, really, really high here. And that's why it's good to invest to know these technologies combined, Docker and Kubernetes. Okay, so finally, what are the recommended necessary skills? What do you need to know to successfully implement containerization? Firstly, you should know how to build your standalone app. So how to design an image using Dockerfile. We're going to look at this. How to build the image. How to share the image with others. Yes, publish it. And how to download the image and running the container. So you take the image created by someone else and run this container locally. So this is the first set of skills. Next, use existing containers, identify and use of already created images from public repo or from your own repo, as I already mentioned with PyCaret. So they built the image, and now you can take this image, pull this image, and run it locally. So reuse of existing containers. Next, very important skill is file exchange between the container and the host. Container is your running app, host is the computer where it runs, or the server. So you should know how to select and implement the case optimal strategy for information exchange between containers and the host. Yes, this information may be data, but also control parameters or files. You have different methods like Docker volume, Docker bind mount, and networking. So we are going also to cover those things. You'll find it covered in my tutorials below, but also in Docker tutorial, which is, in my personal opinion, the best source of knowledge nowadays. The next skill is capability to build multi-container applications. So designing, provisioning, running multi-container apps, parallel independent services, services exchanging data with each other as services running sequentially. Multi-container apps, which serves as a basis for machine learning pipelines. And finally, and this is final set of skills, quite technical but extremely handy. Image container and volume management from command line or Docker desktop app, or it's my preferred choice, from your IDE environments, integrated development environments. In my case, I prefer Microsoft Visual Studio Code. Image container and volume management, it means listing, removing, creating, cleaning up, purging, etc. etc. So it's like the application ecosystems which may be housekept, which you need to take care about. So that's a brief introduction to containerization with Docker. Hopefully I gave you some inspirations how you can use it. And that's also a brief introduction to our next lectures. Thanks a lot. Happy coding.